Right, here's a question about modulus graphs. The graph of y equals modulus of 2x is just a simple transformation away from the graph of y equals modulus of x. You studied this kind of graph in chapter 3 of your core 3. There'll be help there. Then we've got to sketch on a different diagram a related graph. Now you can do this from first principles. You can work out the x and y intercepts. You can consider where the point of the v would be, or you can do transformations to this graph. So what's happened? Your modulus of 2x has had a minus sign shoved in front of it, and then we've got an extra 4. So you can use transformations of graph to adapt your previous answer if that's the way you want to go. Do make sure that you find the coordinates of the points where the graph crosses the coordinate axes. Your transformations may help, but you may prefer just to find the y-intercept when x equals 0 and find the x-intercept by letting y equal 0 and see what happens. But make sure you get those values. In part C, you've got to solve 4 minus 2x equals x. And the intention is that you're going to draw the line y equals x on the sketch you just had before, so you can visualize the 2 points you want. Each branch of this curve will have its own equation, which you may label on your sketch. So you set up 2 equations to solve. In one case where the modulus will have no effect, in the other case the modulus will have a sign swapping effect. But if you've got the 2 branches clearly labelled with their equations, you've just got to solve a couple of easy equations to find the 2 possible values of x. And once you've done that, you can use those crossing points. If you didn't find what the crossing points were, don't worry, make some up because you can get at least a method mark. Hence means you take those answers and you think about your sketch, and you've got to think about when this graph is higher up than that graph. So you may want to do a copy of the sketch with both graphs on at once, and you just simply highlight the relevant bit of this graph. Maybe it's one range, maybe it's 2 where it's higher up than this other graph, and you should just be able to write down the range or ranges of values for x for which this is true.